Hello all, today we will be covering lesson 5.5, the triangle inequality. You guys will be able to use the triangle inequality theorem to identify possible triangles as well as prove triangle relationships using the triangle inequality theorem. So the triangle inequality theorem states that the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. So while a triangle is formed by three segments, a special relationship must exist among the lengths of the segments in order for them to form a triangle. So say this was length 10, and this segment was length 7, this guy would have to be over 3 to form a triangle. It'd have to be more than 3. Let's say actually instead of plus 3, let's say greater than 3 to be able to form a triangle. If it was exactly 3, that would be like forming another line. This would be 7. This would be 3. It'd just form a line on top of that length of 10. Not a triangle. If it was between 3 and 0, say 2, they would just never connect. But if it is greater than 3, even 3.1, we do have a triangle. So let's decide some of these. Is it possible to form a triangle with side lengths of 6, and 14? What we have to do is we have to add the two side lengths and see if they're greater than the third. And 6 is repeated twice here, so 2 of them look the same. Turns out 6 plus 6 is 12, which is not greater than 14. So this is no, because 6 plus 6 is not greater than 14. We'll do another one. Is it possible to form a triangle with side lengths of 6.8 and 7.2 and 5.1? If we check this out, this one checks out. The next one also checks out. Also checks out. So yes, by the triangle inequality theorem, we're good to go. All right, there is a shortcut to this. You can find the two smallest sides, and those two added have to be greater than the longer side for this to work. If that works, then our answer is yes, and if it doesn't, then our answer is no. So if we use that shortcut here, 8.5 and 11.5 are our two shorter sides, so if we check that, if 8.5 plus 11.5 is greater than 20.5, we're good to go. If not, we're not good to go. And it turns out that this becomes 20 is greater than 20.5. That is not true, so once again, this is no because of this following piece. 20 is not greater than 20.5. And then we can do the same thing here with the shortest two sides. If this checks out, then we are good to go. 4.8 plus 12.2 must be greater than 15.1. That checks out. You can choose to state all three and decide from there. But if we know this particular, the two smaller ones are greater than the bigger one, we're good to go. And then we explain our reasoning. Okay. Then we can actually find a range of values that this works for. So in finding the lengths of two sides of a triangle are known, the third side can be any length and a range of values. You can use the triangle inequality theorem to determine the range of possible lengths for the third side. So I'm going to call these third sides x. So if we treat it like we did before, we have 3 plus 5 have to be greater than x. We're actually going to have all three of them here. We also need 5 plus x greater than 3. And we need 3 plus x greater than 5. Now, one of these won't actually work. So we need to figure out which one it is. We'll go ahead and just start by solving all of them though. And hopefully you see the one that probably won't work is the negative one, because distance can't be negative. We can't just say that this is -2 and say, oh yeah, triangle can have a negative length for its side. It can't. This guy, we can't use him. Instead, we have our 2, so we have our range of values. Our side must be less than 8, but greater than 2. So we can write something called a compound inequality, where you put your smallest number on the left side, and then you write your compound inequality following, making sure your inequality symbol is pointing the correct way. So 2 is less than x is less than 8. So we can do another example, very similar, just this time we have to label our triangle. So xy is 6, yz is 9. I'm going to label this w so we don't get confused with the x vertex here. And solve for the range of the possible lengths. So we're going to have 3 of them. We're going to have 6 plus 9 must be greater than w, because these two added must be longer than this side here. If it's not, then it's not a triangle. We also have 6 plus w must be greater than that side. And 9 plus w must be greater than 6. Once again, one of these will not work. I'll have to figure out which one. Once again, we should not have a negative distance, so this guy is no good. So we have our 2 left, w greater than 3, and w less than 15. So we can write them as a compound inequality. And we're good to go. So this side length must be between 3 and 5 units long. Sorry, 3 and 15 units long. Another example, very similar. We're just following the same process with that triangle inequality theorem. Finding this guy, RP, PR, possible lengths. Once again, state all the inequalities. So we're going to get 12.4 is greater than x. X is greater than 2, or x is greater than -2. Now notice we once again cannot have a negative side length, so that's a no-go there. So we are left with x being bigger than 2, and x being smaller than 12.4. We can write a compound inequality once again. And we're good to go. And then we have another example. We're going to find the range of possible values of x. The figure may not be drawn to scale. So it's just going to add a little bit of algebra in here. So we have 5 plus 7 must be greater than x plus 2. We have 7 plus x plus 2 must be greater than 5. And we have 5 plus x plus 2 must be greater than 7. All the different combinations, we go ahead and solve. So 10 is greater than x. Right now we have x greater than -4. So 2 of these are going to probably seem a little iffy. So we have 10 greater than x, x greater than -4, and x greater than 0. Now, 0 and 4 would be iffy, especially if it was just an x term here. Because you can't have a 0 distance, you can't have a negative distance. But because it's x plus 2, this guy is actually okay. That side length can be 2. On the other hand, -4, if we plug that in for x, would just give us a -2 for the distance of that side, and that is no good. So we can write our compound inequality. 0 is less than x is less than 10. And we are done. Now this one, I don't really like this example, so we're going to do a different example. Give me a second to write in this new example. I believe it is 5x minus 7 and x plus 5 and 2x plus 22. So that's our new example. We're going to go ahead and solve for our range and values of x with these. Okay, so just go around, do every possible combination. X plus 5 plus 5x minus 7 has to be greater than 2x plus 22. We also need 5x minus 7 plus 2x plus 22 must be greater than x plus 5. And we need 2x plus 22 plus x plus 5 must be greater than 5x minus 7, because each of the two additions must be greater than that third side. Go ahead and solve all of these, and then we'll narrow down which ones are good and which ones are not. I'm just going to solve, keep solving. Alright, so I have 3 different solutions here. I have x is greater than 6, x is greater than -5/3, and 17 is greater than x. Now we need to narrow out one of them. Careful with these negatives when we have x values in numbers and in expressions, because for this expression and this expression, it would give us a positive side length. But if we were to plug this into here, it would just become a more negative side length. So that cannot be one of our solutions. Sometimes you will have negatives though. So then we can write our compound inequality with the ones left. That means the side length, or the value for the x to make the side lengths into a triangle, has to be between 6 and 17 units. Alright, and that is actually all I have for us. There is a 5.6 lesson that you can go ahead and watch.